Hey guys, the objectives for this video are to revise stress-strain relationships, revise viscous flow, and to introduce the Navier-Stokes equations. So what we've got here is some relationships between the normal stresses in the x, y, and z direction. Essentially, what we have is that our stresses are linearly related to the rate of deformation. So we've got a pressure here, we've got a viscosity, and then we've got the rate of deformation. So this essentially provides us with an equation to replace our stresses with our strains, and you'll see why that's important when we move on to the Navier-Stokes equation. And then in terms of viscous flow, we also can provide equations for our shear stresses in terms of the rate of strain. So this here is our velocity gradient, and when we multiply our velocity gradient by our viscosity, we get our shear stress. And notice that the partial derivative is in a perpendicular direction to this velocity u here. So that is for the xy, the yz, and the zx shear stress. Then I want to remind you of the conservation of momentum equations. So this is something that we looked at a couple of topics ago. So we essentially have rho gx plus the partial derivative of our normal stress in terms of x, and the partial derivatives of our shear stresses in terms of y and x is equal to our acceleration here. So these are the